Now we're actually going to give an equation, and I'm not going to give you any answers. We're going to actually use the rules of algebra to solve the equation for the unknown ourselves. So we're kind of getting into a new type of problem here. We're going to solve these guys ourselves. So let's start with one that's really easy. X minus 7 is equal to 3. Remember, x is a variable. It could be anything. You know, in the other examples we were talking about, x could represent the speed of that ball, or x could represent the distance that ball traveled, and this equation might represent how that ball travels down the pathway. But we're trying to figure out what x is. Now, this is an equation, so you know that whatever x is, when I subtract 7 from it, I have to get 3. So this particular one is so easy that you can just look at it and figure out what number do you have to put here. You know, what do you have to put here so that you can subtract 7 from it and get 3? Well, 10 is the only number that works. You have to be able to put 10 in here. 10 minus 7 is 3. And there's no other number that's going to work. If you put 11 in here, it's not going to work. If you put 6 in here, it's not going to work. The only one that works is 10. That's the only solution to this equation. But you have to get out of the habit. A lot of students, when they start solving equations in algebra and kind of get these easy ones, you know, they kind of just write down x is equal to 10, no problem. But the problem is, very soon we're going to get to equations that you cannot solve by looking at them. So please do yourself a favor and get in the habit of writing everything down on paper now instead of just throwing an answer out there. Because if you just throw an answer out, I don't know if you know what you're doing or not, or if you just guessed. So here's the deal with an equation. What you need to do, the goal of solving any equation, is to get x by itself. If I can get x by himself, then and I have an equal sign next to him, then I will know what he's equal to, because he'll be equal to whatever's on the other side of the equal sign. So it's like a puzzle. X is over here, he's got some junk with him, and you need to get rid of this junk and move it over to the other side and get x by itself. So we talked about this briefly in the last section. You have a minus 7 here. How can you get rid of subtraction? You have to do the opposite. You're going to do addition. And the way you're going to do it is like this. You have x minus 7 on the left. I'm going to add 7 on the left, like this. And then on the right-hand side, the other rule you have to remember is whatever you do to the left, you also have to do to the right. You know? So on the left-hand side, I have added 7. And because I did it to the left, I also had to do it to the right-hand side. Now on the left-hand side, I have negative 7 plus 7. This is going to go to 0. It's going to basically disappear completely. And so because it did that, on the left-hand side of the equal sign, all I have left is x. And on the right-hand side of the equal sign, all I have left is 10. So I get my answer of 10, which is exactly what we know the answer has to be. In fact, you can take the 10, you can stick it back in here. 10 minus 7 is 3. So this is obviously a really simple problem that you don't really have to use algebra to solve. But like I'm saying, very soon we're going to get to some problems that you will definitely not be able to solve by looking at them. So get in the habit of writing this down. You add 7 to the left, you add 7 to the right. You know, I want to kind of illustrate something to you. Equations are kind of like a seesaw. Right, here's the seesaw. This seesaw is balanced. You know, perfectly in the middle, perfect piece of wood, perfectly balanced. If I do something to the left-hand side of the equation, and I don't do anything else, the seesaw is going to pivot and it's going to be unbalanced, right? If I do something to the left, I have to do the same thing to the right in order to keep the equation basically the same, in order to keep it equivalent to one another. You know, we even talked about this a long time ago in fractions. I told you, you can do whatever you want to the top and the bottom of the fraction as far as multiplication and division, you know, as long as you do it to the top and the bottom at the same time. And I told you that's the way to keep it equivalent, right? So if you have 1/2, I can multiply the top by 2, and I can multiply the bottom by 2. And I'm going to represent the same number, but it might look different. It's the same thing here. With equations, I can do whatever I want to the left and the right-hand side, but if I add 7 over here, I have to add 7 over here. If I subtract 3 on the left-hand side, I have to subtract 3 on the right. If I multiply by 4 on the left, I have to multiply by 4 on the right. If I don't do that, then it becomes unbalanced and it's not correct anymore. So what I recognized here is that I have a negative 7. I want to get rid of it. So I have to do the opposite. I add 7 to the left, and because I have to keep it balanced, I then also have to add 7 to the right-hand side. So let me go and erase this, and what we're going to do is do a ton of additional problems to give you practice with this concept. I promise you that by the time we get done with these problems, it'll be so ingrained because you've seen it so many times, it'll be like second nature. All right, so let's say we have y plus 7 is equal to 12. Okay, so how do we solve this guy? The goal is we want to get y by himself. We have this 7 next to him, plus 7, and that is a problem. So we want to get rid of this guy. The way we do it is by doing the opposite. We're going to subtract 7 from the left, and because we do it to the left, we must also do it to the right. If we didn't do it to the right and we only did it to the left, then we've screwed up and we haven't done anything valid. But as long as we subtract 7 here, we can subtract 7 over here. And by the way, why are we subtracting 7? Because 7 minus 7 is 0. So we basically are trying to get y all by himself. So on the left, all we have is y, and on the right, we have 12 minus 7, which is 5. And that is the final answer. So y is equal to 5. Now, if you're curious if this is correct, you can always check it in algebra. You can take the 5, stick it in here, because y is equal to 5. 5 plus 7 is equal to 12, so it checks out. Everything's correct. All right, what if we have something a little bigger? Negative 37 plus z is equal to 37. How do we solve for z? We're trying to find out what this is equal to. Now we have this 37, this negative 37 sitting over here. We don't like that. The only way we can really get rid of it is to do the opposite. This is negative, so we have to do the opposite of subtraction. We have to do addition. So negative 37, we add 37 to the left. And if we add it to the left, we have to add it to the right as well. In other words, all we did was add 37 here to the left-hand side, and then, of course, we had to do the same thing to the right-hand side. The reason we're adding it is because negative 37 plus 37 is 0. And that basically eliminates everything on the left-hand side. The only thing we have left is z. On the right-hand side, we have 37 plus 37, which is 74. The answer is 74. And again, you can check it by putting 74 in for z. Negative 37 plus positive 74 is going to give you positive 37 for a final answer. And I encourage you to check that just to make sure. In fact, honestly, that is really one of the coolest things about algebra, is that once you get an answer, you can always check it. And you always know if you're right. So if you get wrong answers in algebra, there's no reason, because you can always check your answers to make sure you're getting it right. All right, so let's crank up the complexity just a little bit. What if we have 4/3 is equal to negative 2/3 plus x? Notice there's a couple differences here. The first one is I have fractions in here, which scares off a lot of people. The second one is x is on the right-hand side. It doesn't matter where x is. All you're trying to do is get x on one side of the equal sign. Doesn't matter where it is. You just want to get it by itself. So you want to do this using the rules that we're learning here. So since this negative 2/3 is negative here, we want to do the opposite. We want to add 2/3 to both sides. Because if we add 2/3 over here, it's going to go away with negative 2/3. It gives us 0. It's going to disappear. And whatever we do on one side, we have to do on the other. And by the way, let me say, this is a great example of why some students have problems in algebra. Because they come into algebra, they kind of understand the basic idea, and then they get to a problem like this and they freeze up because they don't understand fractions. Math is so important that you build your skills one skill at a time. If you come in here and you don't understand any fractions, you don't know how to add two fractions, then you can't do this equation. And then if you can't do this equation, there's going to be other things later that you won't be able to do because you can't do this. And then you kind of just, it all falls apart. So it's why I take time to review fractions, and I take time to review adding and subtracting negative numbers, and I take time to review a bunch of stuff, because if you don't get it, you just cannot progress. So if this looks scary to you, if these fractions scare you a little bit, then stop, go back to the section on fractions, and work those problems with fractions until you're absolutely comfortable with how to add and subtract fractions and multiply and divide fractions. Because it's not going to get, that's not going to go away in algebra. You're always going to have to deal with that. So even though this problem looks more complicated, it's not. You're applying the same thing. What you want to do is you want to add 2/3 to both sides. So you have 4/3 on the left. You need to add 2/3. On the right, you have negative 2/3, and we're adding 2/3 to that, Of course, we have our plus x. The only difference between this and this is I've added 2/3 to both sides. And the reason I've added 2/3 to both sides is because negative 2/3 plus positive 2/3 is 0. I'm trying to get x by itself. Okay, I'm trying to get x by itself. So what I have here on the left-hand side, I've got two fractions that I need to add together. Fortunately, the common denominator is already here. I've already got a 3. So I keep the common denominator, I add the numerators. I get 6/3 on the left. And that's all from fraction arithmetic. On the right-hand side, this goes away, and I have x. Now, let me ask you this. 6/3 is really 6 divided by 3, so what is that? So that's 2. So 2 is equal to x. So it doesn't matter that it's 2 is equal to x. It's exactly the same thing as x is equal to 2. You've learned that it doesn't matter if x is on the left or the right-hand side. You still just try to get it by itself, and then you have the answer. So x is equal to 2. That is the answer to this problem. So what if we have negative 3/5 is equal to x minus 2/5? So again, we're trying to get x by itself. On the right-hand side, we have negative or minus 2/5. We have to add 2/5 to both sides to clean this out over here. So on the left, we'll have negative 3/5. We're adding 2/5 to the left, and we're adding 2/5 to the right. We're doing the opposite of subtraction. We're doing addition to get rid of it. And the reason we're doing that is because this is going to disappear. It's going to go to 0. On the left-hand side, we're adding these guys. The denominator is already 5. It's already the same, so we'll just put a 5 there. We have to add the numerators. We have negative 3 plus 2. And we've done a lot of work with adding negative numbers and positive numbers. So negative 3 plus 2, you should convince yourself is negative 1. Because basically the signs are different, so you subtract them, you get 1, and the sign goes with the larger guy. So go back if that's not comfortable to you. You get negative 1 here. On the right-hand side, you get x, which is exactly the same thing as saying x is equal to negative 1/5. X is equal to negative 1/5, and that's the answer. Okay? Now, what do we have next? We're just going to keep working through these guys until it's absolutely comfortable for you. X minus 3 is equal to 12. So there's an equation. How do we solve it? We're trying to get x by himself, so we want to get rid of this negative 3. The only way we can get rid of this negative 3 is by adding 3 to both sides. So we add it to the left, we have to add it to the right. Here, this is going to disappear, so on the left, all you have is x is equal to 12 plus 3 is 15. And that is the final answer for that problem. All right, for our next problem, we have 0 is equal to 5 plus x. So it looks really simple. X is on the right-hand side. How do we solve it? We want to get rid of this 5. This is a positive 5, so we have to subtract 5. So on the left, we're going to subtract 5. And on the right, we're going to subtract 5. So we subtract 5 from the right, we subtract 5 from the left. And on the left-hand side, what is 0 minus 5? Well, that's just negative 5. On the right, this, of course, goes away. We just have x. So all you have is x is equal to negative 5. And if you're unsure, just take it and stick it back in here. Negative 5. So 5 plus negative 5, you get 0. It all checks out. And that is the answer to that problem. So really what you need to do is take your time with these guys and think through it. What do I need to do? It's like a puzzle. What do I need to do to get x by himself? That is your goal. So, for instance, if you have negative 9 plus y is equal to negative 9, how do you get y by himself? Well, here I have a negative 9. So since it's negative, I need to do the opposite. I'm going to add 9 to both sides. So I have negative 9 plus 9 on the left, negative 9 plus 9 on the right. I add 9 to the right, add 9 to the left. That's the only way that it's valid. On the left, of course, this goes to 0, so I just have y. What is negative 9 plus 9? Well, that's just 0. So y is equal to 0.